References and borrowing. The issue with the tuple code in listing 4.5 is that we have to return the string to the calling function so we can still use the string after the call to calculate length. After the call to calculate length, because the string was moved into calculate length. Here's how you would define and use a calculate length function that has a reference to an object as a parameter instead of taking ownership of the value. Let's see, I'll start with the println. Okay, so the length of there is yes. We're going to say S1 len. Oh, sorry there. How about let's see if I remember this correctly. No, that's not it. How about hash bang square bracket allow on dead code? Okay, what's the deal? Argument never used. Okay. So maybe we'll also allow unused variables. Allow unused arguments. Yeah, okay. We'll get there. So we got let S1 equal string let's see, string from hello. Ooh, golly. Uh-oh. Hella. Yes. And then we will put the function down here. Function is calculate length. And parameters s, which is s of type reference to a string. Okay. And it is, and it outputs a usize. Okay. Wait, wrong thing. Which is s.len. Yeah. You don't want to indent that for me? You don't want to indent it for me? Okay, so what have I not done? Now we need, we got the let s1, now we need let len. Let len equal calculate length. Oh, look at that. It knows what I want to put in there. Okay, and it's going to be a reference to reference to S1. Is it not going to get around to tabbing this for me? I sort of thought it was gonna. Alright. Looks like it's gonna run. What's the deal with len? What's wrong with you, len? Okay, now I'm here. Now I don't want to have to move my mouse, but I'm gonna. Okay, len. Okay. Argument never used. So this is len. I'm confused. Because this is the... Oh! Argument never used. Oh, yeah. Dude, Rust, you are just the best. I love you, Rust. 2 spaces there? No, just 1. And then it indented the thing, I think. Get rid of some of the ugly. And... cargo run. The length of hello is 5. Yes, it is. First, notice that all the tuple code in the variable declaration and the function return value is gone. Okay, they're talking about this business. Yeah, we had... Right. Did that before. That was... Whew, that was a lot. Okay, so... second, to note that we pass reference to S1 into calculate length, and in its definition, we take and string rather than string. These ampersands are references, and they allow you to refer to some value without taking ownership of it. Figure 4.5, rendered poorly in VimB, shows a diagram. Note, the opposite of referencing by using ampersand is dereferencing, which is accomplished with the dereference operator, an asterisk. We'll see some uses of the dereference operator in Chapter 8 and discuss details of dereferencing in Chapter 15. Let's take a closer look at the function call here. Let S1 equal a string taken from the string literal hello. And then let len equal the result of calculate length called on a reference to S1. So the ampersand S1 syntax lets us create a reference that refers to the value of S1, but does not own it. Because it does not own it, the value it points to will not be dropped when the reference goes out of scope. Likewise, the signature of the function uses an ampersand, a reference to S1, right? No, that's the signature of the function. So that's here. No, here. This is the signature of the function, right? It uses the ampersand to indicate that the type of the parameter S is a reference. Let's add some explanatory annotations. We have S is a reference to a string, and then here S, so here S goes out of scope, but because it does not have ownership of what it refers to, nothing happens. So up here we have let S1 equal string from hello. Okay, and then we're going to calculate length on S1. Huh. Yeah, okay, so is this... Yes, this is a variable, right? I mean, the variable is... Oh, golly. calculate length. Okay, so let's run through the main function from the top. We got S1. It comes into scope, and it is the result of this from function. It is an associated function, or is it an associated function, or is there another word for it? Yeah, so it takes it stringifies, it turns into a variable of type capital S string. A variable of type string is produced from this string literal. So plop, now S1 has come into scope and it is a string type. Down here, instead of passing S1, instead of S1 moving into the calculate length function, instead calculate length has a reference to S1. And then it results in s.len. Okay, so the output of the length method on S, which I suppose is, in this case, S1. I'm a little confused about, is this a keyword S, or is that just a variable name? Why can't we just say and string here? Reference to a string. Right, because so this is a string. So it comes in as a reference to. What happens if we do that? Oh, I see. So the reason that we had to do that was because we need to be able to, refer back to it. So this S is a string as well in this function definition. Huh. No, it's not. It's a reference to a string. It really confuses me that there's a... It does. I'm confused. Returns the length of this string in bytes. Len references itself. It's a public function. I think it's I want to say it's a method. Isn't it a method because of the dot? Method called on a string. But I guess in this case we're calling it on a reference to a string. And then okay, so then back up here we have calculate length takes a reference to S1, which is a string that came from hello, the string literal, right? Okay. And then we have that. So this is a string from a string literal. This is a reference to the string, and then we will calculate the length of it, and that's this down here. So the reference to the string goes in, and when it comes in here as the parameter, when it comes in here as the argument, it satisfies this parameter, and the parameter variable is called S, and the output is a usize, which is not the same as S. So S is here just to say we have a parameter that's taking this argument in, and then calculate length results in an integer. And the integer is determined from running the length function against the argument, which we're calling S because it's about to come in and go bye-bye. So it doesn't matter what we call it. That could be pickle. But then the output is the result of the len function. Okay, got it. So then the len function outputs from here, and then len, which is a usize type, comes into scope. And that is just a... Is that a copy type? Is that a... Does it have the trait copy? I don't know. I think it does. So then we can... Then println gives us the length of... the length of S1, right, which it's okay. Oh, okay, so if S1 had come in to here, if it's not a... Well, what happens if it's not a reference? If instead it gets moved in. Okay, so now, what does this say? Mismatched types. Well, let's match them. Right? So then it comes in as a string. This thing was looking for a string, so that's great. Comes out here as a usize. And this usize is in scope for this function, but S1 is not. Let S1 equal string from hello, borrow of moved value. Value borrowed here after move. Move occurs because S1 has type standard string string, which does not implement the copy trait. Okay. Does it say moved after borrowed? Value moved here. Borrowed here after move, right. Yeah, after it's moved. It has moved. It moved into this, and it got stuck, and it got stuck down here somewhere. This is the scope where it was, and then when this happened, it was dropped. S1 was dropped from scope. Dropped. And it was dropped. And then, because what came into len was something totally different as a usize, which has copy, which is fine. Right. So what happens then is if we have this... ooh, that wouldn't it. If we have this reference, so if we're expecting a reference and we get a reference, then the reference has... So what we're passing around is not the... it's not the value of this. It's not the string data in the heap. What it is the pointer to the string, which is on the stack. And that we can pass around, and it doesn't get dropped at every brace. Whew. So jump down here. The scope in which the variable s is valid is the same as any function parameter's scope. But we don't drop what the reference points to when it goes out of scope because we don't have ownership. When functions have references as parameters instead of the actual values, we won't need to return the values in order to give back ownership because we never had ownership. We call having references as function parameters borrowing. So this is borrowing right here. Having a reference as a function parameter is borrowing. That right there. As in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. So, yeah, you lost me there because when it used to be a string, how did they juggle it before? with the ownership business. Passing it around. So that's here. So here we've got calculate length takes a string and it puts out a tuple, which is a string in a U size. Okay. Right. And then we're going to say let s1 is string literal from hello. I mean a string from string literal hello. And then let this tuple s2 and len be the result from calculate length on s1. So s1 comes in, calculate length, and then comes out here as s2. Yeah, they just renamed it. And then we have println. The length of s2 is len. Okay. So what happened here? It's possible to return multiple values using a tuple. Because with the tuple you get to change what it's called all the time? No, okay, multiple values with a tuple. Yes, because it's tuple. So when we did it before, gives ownership. Okay, what is that? Gives ownership. So the function gives ownership, in this example, it doesn't have any parameters, and the result is a string. And that string is some string, and it is the string literal hello converted into string type. Down here we just say some string. So there it is. And then up here, we let s1 equals the output of gives ownership, which is called some string. Okay, and then let s2 is string from hello. Let s3 is take. Does this even do anything? Let s3 equals takes and gives back s2. What's takes and gives back do? Function takes and gives back has a parameter, and it is a string of type string, and it results in a string called a string. What? This is some complicated stuff. It's breaking my brain. And by the way, if you are someone on YouTube who discovered this, I'm doing this. Welcome. I'm glad you're listening. That's great. This is really just for me. It's not just for me, but it's for me. So, you know, I'm doing what I want. I want to be able to get to it. Okay, so I learn by listening. And I have a habit of reading out loud and recording it and listening to it. But I thought it'd be nice to have it on YouTube, so I'd have the visuals to go with it. Where was I? Oh, we're here, and then how long have I been running? 24 minutes. I sure hope that I'm got audio. I did one of these, did two of them, like an hour or more, yesterday or the day before, and I think I just didn't have the mic input on the right channel. Audio input wasn't from my mic. Yeah, and my internal microphone doesn't work. Okay, so I read that. Let's take a closer look at the function call here. We did that. Explanatory annotations. Okay. The scope in which the variable s is valid is the same as any function parameter's scope. But we don't drop what the reference points to when it goes out of scope because we don't have ownership. When functions have references as parameters instead of the actual values, We don't need to return the values in order to give back ownership because we never had ownership. This is where I got confused. We call having references as function parameters borrowing. As in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. That sounds like it contradicts what they just said here. I mean, I know it's just an example, metaphor, but no, as in, excuse me, I know it's just a simile. We don't need to return the values in order to give back ownership. Yeah. Well, it'd be like, okay, how about this? When I don't lend books, right? Because I take obsessive care of my books. And I hate the idea of lending a book, like lend someone a paperback, and I hate the idea of them giving it back to me because it's gonna, because gosh, you can't make people do stuff. You can't be the guy who lends somebody a book but then says, wait, before you borrow this book, let me show you how to read a paperback without breaking the spine. I think I've done that before, but I don't want to be that guy. So instead, if someone's going to borrow a book from me, I'm usually pretty excited that they're interested in it. And so I say, you know what? Take it. It's yours. I give it to them. Because I don't want to have to suffer from receiving back a book with a broken spine. So in that case, as in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. So that's not borrowing. That's me telling them, hey, take this book. It is now yours. But before, so now let me read this one. It says, when functions have references as parameters instead of actual values, we won't need to return the values in order to give back ownership because we never had ownership. So it doesn't say anything about dropping, right? No, here it is. The scope in which the variable s is valid is the same as any function parameter's scope, but we don't drop what the reference points to when it goes out of scope. So back to me giving away a book, like Orson Scott Card's Ender's Game, it has a special place in my heart because it was the first book I ever read on purpose and enjoyed. So I've bought, I don't know, a dozen copies of that book over the years and just given them away. And what if there was a rule that said, if you take a book if someone gives you a book, right, you only get to keep it. It's only yours until you put it down somewhere. And then it is no longer yours. You can't have it anymore. So what you're doing, the function you're performing, is carrying this book around. So you carry the book around, and then if you ever set it down, if you ever drop it, it's gone. So if that's how books worked, then that's kind of like what strings do. So a string comes into scope, and then the function or whatever's going on in the braces has the string, and as soon as they get to the end of the brace, it goes away. Because they can't just exist out in the world. Books are dangerous. Okay. Yeah, this is a little confusing. Analogies are hard. So here we go. What happens if we try to modify something we're borrowing? Whoa. Yeah, see? That's some poof. Yeah, modify. Break the spine. Try the code in listing 4.6. Spoiler alert, it doesn't work. Okay, they got me with that. That's cute. So here we go. We got function main. So I'm gonna do this little trick. I don't know if this was in the one that I didn't get audio for, but watch this. I'm gonna rename main and call it what do I call it? What are we doing here? Borrowing. We'll call this borrowing. This function is now called borrowing. So now I can pretend like it doesn't exist and go up here, and I have unused variables allowed, so there you go. F in main, one of them's, and one of those. Now what are we gonna do? Let s equal string from hello, and then change what? Oh, it says change function. Got it. Well, I'll put it in order. Why not? Okay, let s equal string from hello. Oops. No, go back. What did they do? There we are. And then we will call the function change on it, which doesn't exist yet, so we're going to get yelled at. Where am I? There? Yes. Okay. So change ampersand s. Oh, that's not where it is. Ampersand s. And then, yeah, I get it. And we'll go ahead and put change down at the bottom. It really doesn't matter. Doesn't matter. It's a whole mess. Declare the function change. So change has a parameter, and the parameter is some string of type reference to string. Okay. Oops. Oh, I accidentally hit both buttons. There we are. And the, oh wait, change, okay, so change takes that parameter and then does a thing, and then, what the heck, why is there, I don't understand how this, I don't understand this yet. To have a function, right? The function takes the parameters, okay, and then we have the brackets. This is what the function is doing. This is the function body, I guess. But then there's this at the end, the semicolon. So what does this function do? Well, oh, it pushes. Here we are. So there's a method run on some string, and that will be the result of the whole function, basically. Having that method. Yeah. This method is the result of the whole function. Yeah, so why is it, I mean, does that mean this is a statement, right? Because there's this. It's not an expression, it's a statement. And maybe functions automatically run the last statement as their result, even though it's a statement and not an expression. I don't know. Evidently, if that's, yeah, if this code, well, the code doesn't work. That's the point. Push the string. Oop, that's not what I meant to do. Push stir. Okay. And then we're gonna take world. Okay. Yeah, it's telling me it's not gonna work right here. It says some string is, you cannot borrow dereferenced some string. Look at that. does that mean pointer? Cannot borrow star some string as mutable as it is behind an ampersand reference. Some string is an ampersand reference. Reference. Some string is a reference, then ampersand. As it is behind a ampersand. So they don't want me to say the word ampersand. They didn't think about it. They didn't think about it like that. As it is, if you're curious, here's how you know if you're supposed to say a or an. If the sound of the next word, if it doesn't matter if it's typed as a vowel or a consonant. So this is neither. It is a symbol, but the word ampersand starts with an A, right? But even that doesn't really matter, because what really matters is that it starts with a glottal stop into the vowel, which in American Standard English, at least, we don't consider that to be a consonant. So, come back. As it is behind an ampersand. So the glottal stop goes away, an ampersand. Nobody cares. But really, they don't want me to say ampersand. I'm pretty sure. Because these guys are pretty smart. They're not going to say, as it is behind an ampersand reference. Why do I get so distracted? Some string is an ampersand, is a reference. So, the data it refers to cannot be borrowed as mutable. Oh, so that's not the issue that I'm borrowing it, it's that I'm mutating it. And I'm changing it. That's what the function is called. Can't borrow pointer to some string as mutable. Is that a pointer? I don't know. I don't know anything about code, but I hear people talk about pointers. So what do? I mean, can I? Wait, you can't have a mutable reference. Let's keep reading. I bet it's going to tell us to put the word mute in there somewhere. So it doesn't work. I'm not going to try to run it. Attempting to modify a borrowed value. Here's the error. Yeah, we looked at it. Oh, well here they say use mute string. Well, okay, so if I do this, maybe it'll... You're not going to tell me to use mute string? I want to know about using mute string. Yeah, I think I turned off a light bulb. Used to be a light bulb. See, maybe if I try to run it, well, it'll tell me there. Yeah. Help. Consider changing this to be a mutable reference. Yeah. Mutable references. We can fix the error in the code from listing 4.6 with just a small tweak. And that small tweak is right here. And mut. Well, first of all, mut. Did I say mut before? No, okay. So we're not even really talking about borrowing and stuff. We're just talking about mutability, which we already covered. So we're letting mut s equal this stuff. Change reference to mut s. Change the string. Some string of type mutable reference to s. Can do. So, not that. So, function main, let mut s equal a string from hello, and then we'll change, mut s, we sure will, and then down here, some string is a and mut, a mutable reference to a string. Oh, it's beautiful. So let's watch it go. Do I want to put borrowing in main? I think I do. So that'll be down here. We'll say, yeah, borrowing. Now, oh, I allowed dead code. Yeah, hey, look, this I didn't have to do that because I'm allowed to have dead code. The length of hello is 5. When I never told it to print anything, did I? That sounds kind of familiar. So let me get in here right fast and say println. We'll say println. Why is it not giving me an error? That's curious. Huh. Shouldn't there be an error there? I haven't put any reference there. I didn't put, not just that, I didn't do this. That's why. Oh, golly, come back. Yeah. So, just give me some of them. Give me one of those. And then we'll say, am I in? No. There we go. S? No, we need the output of change, right? So we changed it, but wait. What's the push it with the sum string? So I'm just supposed to. What? I'm so confused. Let me run it over here and see what happens. Nothing. Run it over here. Did they forget something? Am I missing something? Well, let me solve this problem then. Borrowing. Oops. I'm not going to worry about you. Okay. So right now what we have in scope is the output of the function change, which should be some string dot push stir world. So when m was mutable reference to s. So then what we should have is, I don't even know. What does this do? Push string appends a given string slice onto the end of this string. So then assert equality. What is that all about? Man. Well, let's try. Let's try this. So S came in, we changed it. So I mean this should be, okay, so this should be 2. Oh baby, I'm getting somewhere. Got it. Okay, right? Oops. Okay. So if I put another little thingy here, okay, and then this is going to be S. No, it's going to have to be, what comes out? What does come out of the function change? What comes out of the function change, so it's a mutable reference to S, so that means we're just going to refer to S again. So, like a ampersand S, will that do it? And then, ampersand S dot, wait a minute. An output of change is, push string. I am so confused. So that means I shouldn't have to put push string in here, but there's no, it's not calling it anything, right? It came in as some string. Then some string is dropped, right? Or whatever. The muted, so the string comes in as muted. There's no reference type here. Wonder if I want to get this to work. I mean, does it just come out as S? Is it going to make this whole thing be hello world? Come on now. No, okay, delete until the comma. Oh, of course. No, go away, Q. Delete until the comma. And then change until the closed paren S. So we're going to do it. Find out. Yeah. So I guess that's the whole point of mutability, right? Is that I got S, so I have S, blam, and S is mutable, so ho, watch out, that ain't gonna stay the same for long. And it came from hello, right? And then the first thing we do is we take a mutable reference to S. Wait a minute. But then S itself got mutated? It's mutable. It is mutable. Alright. So then we have a reference to mutable S changed. And it comes out as it's still just mutable S. It should come out as a reference to mutable S, right? And then if I just use S instead of a reference to mutable S, it works. Why? Okay. Mutable references. Let me read through this again. We can fix the error in the code from listing 4.6 with just a small tweak. Adding, first we had to change S to be mutable. Then we had to create a mutable reference with reference mute S and accept a mutable reference with the parameter some string of type mutable reference to a string. But mutable references have one big restriction. You can have only one mutable reference to a particular piece of data in a particular scope. This code will fail. So in that code they say let muta, and I guess then they're going to fix it. So whoo-wee. How much can I do? 50 minutes? Where's the stopping point? Yep. So I'm done. I'll come back out. I'll come back. I'll watch the video to see when I need to come back.